about 5-6 years. Got into PowerShell mostly because of necessity, and through various years of hacking on PowerShell, Google foo, everything else, started to develop tools that help me in my day-to-day job of just, managing the chaos of being a security professional. So, a little history of PowerShell. PowerShell came about in the Windows 7, Windows 2008 era. Microsoft released this brand new command line looking thing called, PowerShell, where now what you had is access to the entire .NET library, the entire .NET interaction. You could natively interact with and pull in .NET codes, and it was an object-oriented shell versus the standard command shell, which is a text-based command shell. What this essentially did was open up the entire gambit of the ability to interact with the Windows API, with the Windows kernels, with any library that any .NET application could interact with. So without even compiling code, without even, even doing major program application, you could script against the same APIs and the same procedural calls that, C# developers, VB.NET developers, .NET developers were working with. At the same time, Microsoft had a major shift in the way that they were designing their operating systems. Now, rather than designing libraries first and then, doing some command line stuff on top of it, they were designing the way that you interact with the system as PowerShell commandlets first, and then the GUIs do nothing more than call PowerShell commandlets in the backend. So, for the Windows administrators in the building, huge mindset shift came about in the Windows 2008 R2 timeframe, where you started interacting more and more with PowerShell commandlets and less the point-and-click methodology. Well, for security professionals, it opens up quite a few interesting options. So now that we have access into the API, let's back to duplicate. Now that we have access into the APIs, we can build our own tools within the shell itself, without compiling code, without putting tools onto the system, without really interacting and compiling code and dropping executables on the system and dropping malicious files that might be picked up by antivirus. You're just operating within the PowerShell environment, and it just looks like another script on the system, right? The other thing that you can do is, without a heavy investment into building a Windows Forms-based or WPF-based tool, you can build some pretty powerful capabilities within just the PowerShell environment itself. So what we've got on the CD, what I've provided you, the grab bag is just kind of a grab bag of scripts that I've either created, run across, various pieces of things. Function templates, just kind of a start point to making a function. PS_NESSDB is kind of a pet project of mine. This uses PowerShell to take large Nessus files. I'm talking 200, 300, 400 megabyte Nessus files, put them into a Microsoft Access database, and then export reports. And it's got a front-end GUI that I can interact with and do database queries against the Nessus results. That really, when I started to deal with 3,000, 4,000, 5,000 host Nessus files, I was able to get the capabilities to actually manage that. PS_Yum repo. This is actually a funny story. This one is a PowerShell version of synchronizing a Yum repo, right? So I was in an environment where I didn't have access to rsync. I couldn't just, download and bring something in from home. So I wrote a PowerShell module that goes out, enumerates a Yum repo, goes through the various artifact lists, and then downloads each of those, does hash checks, and basically keeps it synchronized for me. So SQLCE, I'm starting to test working with the SQL CE engine, and then this is Dave Kennedy's Trusted Sec PowerShell Proof of Concepts, just for your reference. Count report is something that is able to does some queries off of my Nessus database, and so that's just kind of stuff to, just thrown in there for a grab bag. Labs is what we're going to go through today. This is just a couple kind of core concepts to get the idea of PowerShell. There's way more in the PowerShell environment that I can possibly even hope to cover in 2 hours. And the more I get into it, the more I realize that there's just an entire world I don't know of PowerShell. So this is just some quick labs. PowerShell basics, working with commandlets, working with variables, working with pipelining objects, importing .NET objects into the environment. Just working with selects, filtering, stuff like that, just kind of basics. Using .NET objects and bringing .NET objects in and using those. Number 3 is the poor man's port scanner. Using system.net.tcp client, we can open up a TCP client, see if it connects, doesn't connect. If it doesn't connect, that port's closed. If it does connect, hey, that port's open. Not nearly as capable as Nmap, but it'll work in a bind, and it's only, I think, 15, 20 lines of code. Kind of the starts of a web crawler. This is mostly just interacting with a web page, pulling down the content, filtering links, doing encryption, AES encryption, just within PowerShell. So being able to encrypt an object using the system.security.cryptography libraries, and then turn around and decrypt it in another script. Working with Nmap results. Going to go through, work with some Nessus results. I've got some sample Nmap and Nessus results in there. And then number 8 and number 9, if we get to it, are a couple of the cooler blog posts that I've seen. One is building a full two-way TCP client server environment where PowerShell sets up a TCP server and then has a client call it and then respond to it. And then recreating Netcat within PowerShell entirely so that you can do all of the various things with Netcat without actually having to put the Netcat binaries on the system. Modules, these are two of my favorite PowerShell security-based modules. PoshSec mod is from Carlos Perez at Dark Operator. So this is a module of utilities, parsing utilities, database utilities, registry utilities, various assemblies. So, and then Powersploit, which I'm sure a lot of you have heard about. This is a exploitation framework and offensive security framework by Matt Graber that really brought a lot of the security impacts to PowerShell to light. Matt does a lot of very advanced things in terms of reflections, dynamically loading DLLs, dynamically compiling applications in memory. His post-exploitation mindset of nothing touches disk. He's infused all throughout here. So this is a great example of a module, and lots of great advanced things in there to reference. References are just various helpful guides, cheat sheets, basic things that you can, as you go through and start learning more about PowerShell, throw them in a references folder so that you can look to see if anything applicable to what you're looking at or what you're trying to deal with might be in the references before you go out and start Google Fooing it. A lot of this is just for your future reference. And then the utility folder is just a couple of WMF 3.0 and 4.0. So Windows Management Framework is the official title for PowerShell. I put in Windows Management Framework 3.0 and 4.0 just in case you guys are still back on 2.0. the 3.0 and 4.0 framework really improved on what came out with Windows 7 and the Windows Management Framework 2.0. And you'll see that when we get into the web stuff, where in PowerShell 2.0, you have to go through and build this whole system.net web client and deal down at the .net level. In PowerShell 3.0, they made a commandlet that is invoke web request, right? And it handles a lot of the back end dealing with those things for you. Really makes a lot of stuff easier, simpler. So those are there in case you want it. And then resources, you guys can see that. I'll bump this up a little bit. There's just some various resources on the internet, as you start to get into PowerShell more, that are good places to start, good places for information. All right, so lab 1, first off, let's open up PowerShell. Right, so it looks just like the command line used to, except for, if you notice, here you see this PS. Okay, PowerShell is completely revolves around commandlets. Okay, commandlets are built-in functions that Microsoft provides to kind of help move in and out and work with the PowerShell. So a couple of the key ones that I've used is get help. So as you might surmise, get help allows you to query what does a commandlet do. So if you do get help of, get child item, right, it'll give you a list of various aliases, syntaxes, how to call it, remarks, and so that's, without going out to the internet, just a quick way, if you're having trouble or struggling with the various switches, options, or commandlet, you can use get help. Get command as the name leads to, right? Get command shows you all of the currently installed commands that you can call. Okay, obviously this is too big of a list, right? But you can pass a verb to it and get just all of the commands that are get. One thing about the verbs, all PowerShell commandlets are a verb now, okay? So get file hash, get Nessus reports, get service, right? Convert from CSV, convert to CSV, out file, get child item, where object, for each object, select object. You notice it's a verb noun. A couple others that we'll be dealing with: get child item, gets files and folders in the system drive. Get content, loads the contents of a file into memory. Get members, gets the properties or methods of an object. Where object allows us to filter. For each object allows us to quickly iterate over objects. Select object allows us to select components of an object. So if an object has 10 members and we only want 2 of them, we can just say select the name and the size of the file, and it'll pull back name and size for us. And we won't get all of the other items. Out file sends outputs to a file. Out null is the same thing as sending it to dev null in the Linux world. Out grid actually brings up a window for us to interactively, it's basically a table that you can scroll in the GUI. New object creates an instance of a new object. Write hosts writes an output to the host, and write output sends specified objects, or sends specified objects to the next command, or it displays it back on the command window or on the PowerShell window. So let's go ahead and change directory over to where the labs are. Okay. And if you remember from the get help of get child item, it's got an alias of dir for directory, an alias of ls, right? An alias of GCI, or the full command. We're all running the same command line. Okay? And what this is returning is an object with mode, last write time, length, and name of each of the objects underneath that labs file. Okay? Each of these are directories with those names. Now, that's what's being printed. Okay? If we do get member, this is actually all of the members that are returned, okay, from the get child item, right? So it's got both properties and methods that we can call. And of particular note, in the properties, you also have full names, extensions, last access times, last write times, parent folders, root. So if I do you guys do get child item and then pipe it. Let's go ahead and lit up the screen. Of course not. Okay, so what do you guys think this is going to do? So type, go ahead. So I'm doing the get child item command, right? And then I'm piping it over into the select object function. Guys, remember, select object selects the objects or object properties, right? Now, rather than getting the full thing, right, I'm just pulling back the name, the full name, and the extension. Okay? Extension's not very smart because it just looks at whatever's right after the period. Okay, the other thing I can do is I can pass recurse flag to get child item. right? What this is going to do is it's going to go through all subdirectories and find every file in all of the subdirectories. I then pass this to a for each object, right? Either one of the special characters, one of the special things is $_ when you're passing something to a pipeline. $_ will allow you to use whatever the variable is that's being passed on the pipeline. Okay, so get child item recurse for each object. So I'm just going to do write host $_ dot name. Okay, so this is going to do a for loop for each object, and write out to the host all of the names of the objects. Okay, a couple more examples that you guys can run on your systems. Right, same time. Get child item, select object name and length, sort by object length. What do you guys think that's going to do? So it'll give you a list of your files with the biggest files in the top, smallest files in the bottom. Okay. Git command, verb write, output it to get help, so for it. Each object will get passed to get help, and then that'll save it out to a file, write commands.txt. So you can make yourself a text file of all of the help. Okay. So if we use get content, let's go into the Nmap lab. All right. We use get content. Let's go with Nmap scan me. All right. We're going to use the select string for just the ports. And that'll print out the lines that have port on it. Okay, not really useful yet. Okay. But what we can do is we can save these to variables. Right? So I can say, let's say directory equals get child item of this directory. Okay. Now that's stored in a directory variable. Variables are annotated by the $sign and the name of the variable. And it's the actual object that's stored in there. So unlike command shell, where if you store the output from a command, into a text file or into a variable. You're just getting the text. In PowerShell, we're getting the full object. So let's you guys go ahead and try this one, where we're going to make a variable. Let's change my height real quick. We'll store variable name. Diego Montoya. I'll put it to this right host command. Here we're using the variable again. And you get the famous quote. So it inserts the variable to the command. Okay? So you can also, when you're making variables, typecast a variable into a specific type of object. And if PowerShell has the ability or logic to change one type of variable into another, it will automatically do the conversion for you. So one of these that I use all the time, and go ahead and do this with me, is if we go into this nmap directory, let's go ahead and change this backspace.xml into an actual XML object that we can interact with. Okay. So if I use the brackets, bracket the type that I want it to be, bracket XML, and then do a get content of backspace.xml, right? This is going to store those Nessus results into an XML object that I can then interact with. All right? So on your guys' system, go ahead and cd over to this nmap directory and enter that command with me. And it doesn't look like it did anything, right? If I look at that XML file, now rather than just having a big string of XML, I have a full object that I can interact with. Okay, that I can loop through, that I can select on, that I can do, where objects on. Okay. So if you're familiar with the XML constructs of an nmap export, right? I can now do XML dot nmap run. Okay. And this will start to show me the subnodes of that XML object. .host. Now we see all of our hosts. It was in that XML object. So we were able to go from this very complex somewhat unwieldy output from Nmap. With a single command, now we're able to turn it into an object we can interact with, right? And that we can search through, that we can step down through, that we can loop through. So Nmap, mapper on host, for each object, show me the OS subobject for each of those. Yes, these are curly braces. So with the for each objects, it's for each, curly brace, $_ to work with the object, and then what you want to go with, so $_ ports, and then end curly brace. I can also wrap the entire thing in standard parentheses, right? And make an array object out of the returned for each results. So here I can step through and I can see on that first host, these are the ports that came back, right? Not 100% useful at this time, okay, but when we get into the Nmap stuff, you'll see how you can quickly, through some of the functions, go through and start enumerating very quickly the results from your Nmap scans. And then reacting on it. Is there any questions on that? Oh, I went through it kind of fast. Any questions on typecasting, storing objects, commandlets, pipelines for each? Go ahead. Let's get variables. So if you type the get variable command, you'll see all of the variables that are currently within the PowerShell run space. Okay. So you notice our get variable XML, that's where we can see that we've set the XML variable. So there's a lot of other variables that are just part of PowerShell running, like its error logs, the current host that you're on, what your home directory is, your PowerScript, your PowerShell home, PS version table, which allows you to see what version of PowerShell you're running. PWD, which is similar to the Bash PWD, shows you what your current location of the command line is, what your current working directory is. And this is important in scripts so that you can get what the current working directory is, even if it's being called from outside of the, so if you're calling a script that lives somewhere else on your system, but you want it to act on the current directory that you're in, you would just bring back what the current directory that you're working in as the PWD variable. And then you could use that to interact with it. Save, outputs to it, load files from it, stuff like that. Another thing that we touched on is the ability to save .NET objects and COM objects into variables and then work with those. Just like you're, programming in real time, I like to think of it. Okay, so here I'm going to pull in a systems.diagnostics.stopwatch, right? So I'm going to pull in a .NET stopwatch. I'm going to start the stopwatch, and then I'm going to stop the stopwatch, and then I'm going to pull back the time that was elapsed on it. Okay, so without having to compile anything, let's go ahead and start it. All right, now I've got a stopwatch stored as the SW variable. Okay, I can pass this to get member, right? I see all of the members, methods, and properties that my stopwatch object has. Okay, if you look this up on MSDN or TechNet, you would see those members, those methods. Okay, now I can do a stopwatch. Okay, I can call the start method, right? So here now I've got a stopwatch that's running in the background that's timing, how long it's taking me to talk. Stopwatch.stop. Okay, now my stopwatch is stopped. Stopwatch.elapsed. Looks like I talked for 11 seconds. Okay, stopwatch.elapsed milliseconds. I'm hitting the tab button to autocomplete. So just like in Linux command lines, tab's the autocomplete. Okay, stopwatch.elapsed milliseconds. Now I get back a single integer of the elapsed milliseconds that the stopwatch was running. Okay, I use these to give me feedback on how long scripts are taking to run. It's a little bit more accurate than the built-in measure commandlet that PowerShell gives you. I can also bring in an entire application by calling its COM object invocation. Okay. So if I want to build an Internet Explorer process in the background, right? I've got Internet Explorer running in the background for me. I can tell him he's visible. I can tell him where to go. Right? I can interact with the entire object class. Okay? I could say, hey, give me back the document that you currently have in your open tab and store it as this HTML object. Right? And then I can invoke his deconstructor, tell him goodbye. But going back to managing variables, just because you call a deconstructor, right? Okay. So he's quit. That's still technically a valid object, right? But PowerShell, when you called the quit command, Internet Explorer died out from behind him. That's why we just clean up after ourselves and do the remove variable. Sorry. Remove variable takes the actual name. Okay. What I was passing it was the actual variable. So it was looking into the variable and passing system com object, the phrase system com object to remove variable to say, hey, remove the variable system com object. All right, is there any questions up till now? Okay. I know it was kind of fast and, not as heavily interactive. Some of the stuff coming up. Okay. Now let's go ahead and open up. With PowerShell, it comes with its own built-in scripting environment. Okay, its own IDE Lite. Okay, and it's a very light IDE, but it allows you to interact with PowerShell as well as work with scripts. Okay, so it's Windows PowerShell ISE. You guys have Windows PowerShell 3.0 or greater. You get this neat little list of all of the possible commands that are currently loaded into the run space. On the side. Okay. And you have a place that you can edit scripts, and a place that you can run scripts and run commands. Is everybody there? All right, so in Windows PowerShell ISE, what we're going to do, right, go to my temp folder, okay, go ahead and load up base64.ps1, base64 input.ps1, and convert to string base64.ps1. You guys see that okay, or do I need to make the font bigger? Is that big enough? Bigger? Higher? Lower? Bigger? Alright, I don't want to go too big. How does that look? Okay. All right. So now we're entering the realm of PowerShell scripts. Okay, this is between PowerShell scripts and PowerShell modules. This is the core of how various, PowerShell functions are passed around, stored, saved. Makes it so you don't have to retype everything in over and over again. Makes it so you can email a cool script to your buddy. So scripts, just like every other scripting language, reads top to bottom and just executes the commands as if you were typing them in. Okay? So with this PowerShell script, I'm storing a string, right? I'm using a .NET method call, okay, which is annotated by the brackets, 2 colons, and then the method that I want to call. This allows me to call a .NET method without having to build an object of it first, right? So rather than having to build a system.text.encoding object just to call the utf8.getBytes function, I can just call it seamlessly in one line and invoke that .NET method to get the UTF-8 encoded bytes of my string. Storing that as a bytes array, doing the same thing to use the system.convert library to convert that to a base 64 string, writing out that base 64 string, and then going in reverse. Okay, converting the base 64 string, calling the from base 64 string method back into bytes, calling get string, turn it back into an output, writing the output. So go ahead and run that and tell me what it does. To run it, this little play button. Run script, or if you're familiar with Microsoft IDEs, F5 is the run command. So while we're waiting, does anybody have an idea what it's going to do? Well, turn things to base 64, turn it back, write the output to the host. Yes. So, it says that. Okay. So, the execution policy, this is a Windows security thing, right? So in order to prevent you from running PowerShell scripts, there's a flag with Windows PowerShell that's called the execution policy. Command get execution policy, right? You can get what it's currently set at. Okay, mine set is unrestricted because I know what I'm running on the system. Okay, if it's restricted, it means that you can't run PowerShell scripts whatsoever. It's still not a block to actually running PowerShell because you can simply copy the entire script or copy the entire module and paste it, and it will still run and build all of the functions, and you can still use it, right? It just doesn't allow you to quickly call a script. Remote signed means that it'll run the PowerShell scripts if it's signed by a trusted code signing certificate, or it's signed by something in your local trusted certificate store. So also in that utilities folder is the make cert util from Microsoft that allows you to build a self-signed certificate. And then using these commands, you can sign your, you can go ahead and sign your signature, or sign your script, right, with your new fancy self-signed certificate. One thing to note is that in order to change the execution policy, you have to be running PowerShell as an administrator, right? Because PowerShell respects user rights throughout the environment. So if I try to change it here, all right, it's going to give me an access denied. PowerShell doesn't have administrative rights on the machine. So if I go to PowerShell, right, this is just the whole right-click run as administrator. This PowerShell. And it'll ask you if you really want to elevate it. I know that's like way too. We'll just do this real quick. Set execution policy remote signed. Allows me to do it. Set execution policy unrestricted. Allows me to do it. So did that help? Let me know if I'm going too fast. The other thing you can do with scripts is you can use a parameter block to pull input from the command line. Right? So here, this is going to use the parameter block in order to set my string variable. So rather than like in here where I'm setting it within the script, here I'm setting it by the command line. And then it'll, once again, run through, base64 encode it, write it, base64 encode it, write it out. I can also turn this into a full-blown function. Okay, functions are like commandlets, right? Other than they're not compiled and they're not, added in and embedded into PowerShell. So by running this script, I'll add a function that's convert string to base64, and also add a function convert base64 back to a string. Right, which does nothing more than take my parameter. Also tells me that 1, you can't run the function if you don't have a string to encode. And also, if a string is being passed across the pipeline, go ahead and use that. And then, if they really need to know, give them a help on what that parameter is. A couple other unique things about functions that you can do with functions, but you can't do with just straight scripts. One is this commandlet binding. Okay, this opens up a bunch of built-in functionality in terms of being able to use debug flags, write verbose flags, some of the other more advanced functionality that's embedded into commandlets. Also, if you're passing an array of objects into a function across the pipeline, you could set up a begin processing that will run once at the beginning of processing, a process that will run for each of the items in the array, and then an end block that's used after all of the items are processed that wraps it up. So that's what those are. Let's go ahead and load this. Go ahead and run it. Runs this for me. Notice it didn't do anything. But now I've got my convert base64 to string. Add that as an input into it, and it decrypts it for me. Right? Okay. I can also take that same string, remember the pipelining, I can push it across the pipeline into it. So if I had a whole list of base64 strings that I needed to convert back into original ones, I could simply pipeline the list of strings into convert base64 to string. Or if I had a list of strings that I wanted to pipeline into and get the base64 for each of those, right? I can build an array convert string to base64. I'll get the base64 of each of the strings that I pass to it. Okay. Remember, I've still got my HTML variable from before, okay, that we got back from Internet Explorer. Just like that, I can also pass that into the same function. And it'll go ahead and build me the base64 encoding of what that HTML page is. Does everybody get how I did that? The last one, the last major type of PowerShell script or function is called a module. This is annotated by the file names PSM1. Okay, this is a module that I built to build a PowerShell logger to save log outputs to a file similar to Log4j, but without having to call .NET libraries or call a bunch of other stuff, kind of more native PowerShell. And in here, in the module, some of the unique things is I can set module-only variables that aren't exposed back out to the general run space. Okay. I can also have both private and public members by using the export module member. Okay, so if I'm calling export module member, only the things that are defined with a export this function will go ahead and return back out to the run space. So where I've got a few internal functions in this, okay, such as the actual write log function, right? If we import that module, okay, import that module in, right, it's only going to get me only going to have the get script info, new log file, and switch log file commands available to me. So if you notice, write log is only internal to that module. But new log file was exported back out to the run space. Okay. You can also, with modules and functions, use comment-based help, right? That can be called by the get help function. And there it'll show you the various things you put in comment-based help. Alright, so comment-based help dot synopsis turns into synopsis. Dot description turns into description. Alright, so does everybody kind of understand the general concepts of PowerShell, the general environment that we're going to be working in, kind of how it's different from commands, the command shell, how it's different from bash, how it can interact directly with .NET objects. Alright, let's go ahead and move on to one of the funner ones. Go ahead and load up in your integrated scripting environment this port scanner, this PowerShell port scanner.py. Right? So this is a very quick, down and dirty port scanner. So it's lab 04. If you go labs, or 03. So here in this one, okay, we're setting port to 80. Saying our network is 192.168.0. Range is 1 to 254, which will scan the entire usable subnet, the /24, 192.168.0. Okay. For each R in range, right? So this nomenclature builds an array of sequential numbers from the start number to whatever the end number is. So 1.10 will give you an array from 1 to 10. Right? We're using the for each command to take each object in that range. Okay. Here what they're doing is a format string. Right? Record 0 dot record 1 using the dash format decorator, passing two variables. Right, to build the IP address. Okay. But since we don't have 192.168, right, what if we were to try to see if CNN's port 80 is open, right? So if we do a this lookup of CNN.com, right? Say our IP is okay, so I've set my IP to CNN.com. This test connection is the PowerShell equivalent of ping. So here I'm going to ping with a buffer size of 32 once the computer name of IP, or the computer name of what's at that address. If it returns true, that means I can connect to it, and it came back that I'm alive. If it comes back false, it says I'm not alive. Right? So if I go ahead and change my IP to 3.168.0.1, run the same thing, because I can't connect to 192.168.0.1. Test connection comes back as false. Throw that in the if clause. So if it's true, so if the host is alive, here's my IP back. open up the socket. Right, using the system.net.sockets.ccp client. Okay, so I now have an open socket between me and CNN.com. So this is a full-blown .NET socket. Okay, I can send GET commands to it. I can send post commands. I can use, I can get the stream coming back from it. But what I'm interested in is, am I connected to it? Right? So whether or not you were able to actually connect to the socket comes back as a Boolean connected. So if the socket is connected, this is the cheap way of doing write host. Same thing as saying write host. The IP is listening to port 80, and then close your socket behind yourself. Call to close. Just get that. And clean up after myself. Are there any questions on that? All right. So for the next one, what I want to do, this one's not in your guys' folder. I made this while you guys were doing the bash scripting for the robots.txt. I was going ahead and creating the same thing in Powershell, right? To show, kind of contrast and compare how you would do something in PowerShell versus how you would do it in Bash. So let's go ahead and download the robots.txt from CNN.com. So here, the URL is www.cnn.com. And in this one, I'm going to build the system.net.web client. Okay. The reason why I'm using system.net.web client is because it's PowerShell 2.0 compatible. If I was to do an invoke web request, it would break on PowerShell 2.0. So I'm making this new object, the web client, and I'm just telling it, hey, download this as a string and store it in the robots variable for me. why I'd like to leave it alone. What's that? So if you put if you put a function in the middle of a string, or if you put a variable in the middle of the string, right, it inserts the value of that variable, or the two-string version of that variable, right? But for whatever reason, when I tried to run all three commands together, it wasn't picking up that URI was a variable, and it was trying to use it literally as $URI. When I came back and ran that command on its own, it worked just fine. So here in our robots function, in our robots variable, sorry, you guys see that we have the string text of robots.txt. Now if I wanted to save this, I could easily go out file, right, and just save that out as robots.txt. Okay, and that'll just pass the strings from from the robots variable, change it into a file, save it on the file system. So there's robots.txt. If later I wanted to call that back in, I could just use get content, pull that string back in into a variable. So next what I'm going to do is I'm going to take the text of robots, right? I'm going to use the select string filter to only get the lines that have disallow. Then I'm going to replace disallow : space on each of those lines with http : www.cnn.com. Right? So I'm taking robots, passing it to select string to filter. Let's go through and just do that one at a time. Right? Okay. Go ahead and make that so that it shows up. Alright, let's try this differently then. So doing select string disallow, let's do where object. Okay. What this is going to do is it's going to pass every line in as a separate object into where object. Alright. So here what I did is I stored robots into an array, splitting on the new line character. That's what I was missing. You guys see how that worked? So now, instead of just one big block of string text, right, I've used the split decorator and stored the results of that into an array object. So now I have an array of UR or the robots.text. Okay. And here, if I do the where object, $_ so it's going to pass each value in one at a time. Dash contains that's what it is. Which is more than I really thought it just in there. Alright. Guess that's what you get for trying to do it real quick. What's that? Okay, so regardless, what I can get is I have an array of values. I can do for each. Use the replace decorator. Replace the disallow stuff. Right. I can also use the same decorator. Okay. Replace sitemap with nothing. Did this right. Okay. So disallow for each item, replace sitemap with nothing. This works as expected. Now cleared out the sitemap for us. Cleared out these. Okay. We can then take the disallow and for each, right? And for each URL and disallow. Okay, copy all this. For each disallow, I'm going to try to do a request to it, right? If I get a response, it means it exists. If it gets a 404 error, or it gets a 503 error, access denied, anything else, it'll throw an error, and it'll cache. Okay, I'll go ahead and write those errors so we can see them. So, if it's a valid object, right, I'm using this invoke expression here. Use the command start to open that URL in whatever my default browser is. If it's not, write an error. So obviously I still have some fine-tuning to do on this one. I'll go ahead and move on to some of the ones that I didn't try to write 15 minutes before I got up here. You guys see how you can interact with PowerShell, use PowerShell to download web pages, start parsing the results, and then creating web requests off of the parsers. All right. Okay, so I've got 20 minutes left. What do you guys think? Encryption and map, or working with Nessus? Nessus? Okay, if you guys go in the Nessus lab, right, I've got this Nessus item that I took this Google Top 1000 on. Right, so each of these websites is the Nessus output. Right, so it's big and long. This guy right here is all 1,000 of them. Okay, all 595,000 lines in that XML file. So one thing, mystery. For those interested, I missed the database that this gets dumped into, so afterwards I'll have to give you guys a RADA link. Go grab it. So I'm going to pull all of these into this Nessus database. It has a table for all of the hosts, a table for all of the report items, a table for all of the plugin info. It's not as normalized as it could be, but it works pretty well so far. So I'm going to go to PowerShell. Make my font bigger for you. It's a little bit too big. Is that big enough for everybody? So what this Nessus database analyzer does is it goes through, I'll open it up in ISE real quick. It's a little complex, but the basic logic of it is to go through and cut out every host report item, right? And one at a time, it goes ahead and loads it into the database. This allows me to, one at a time, go through these 200, 300, 400, 500 meg files. So it takes the path name of the Nessus files that you want to import, the access database that you want to save it in, the log file name if you want to specify a specific log to log into, and then a couple traces. In the begin block, this is where I set up all of the various functions, import helper modules that are in the folder as well. I use this add nessus host.ps1. That's what actually does the parsing of the nessus host result into the file. Sets up logging. Right. One function that I built is I built my own custom .NET application. Because one thing the PowerShell lacks at is the ability to quickly do large numbers of for loops. Okay, so where I was doing a for loop search, looking for those report host item things as part of rebuilding the Knuth-Morrison-Pratt search algorithm, right? In PowerShell, it was taking, seconds to minutes to go through a file. In the PS Nessus utilities, which you'll see in this folder, all right, you'll see where I use C# code to do the same thing. Go through, open up a file stream, and go through the file stream looking to match the bytes using the Knuth-Morrison algorithm, and then it returns an array of file offset locations of where those byte matches were. I then later use that to cut just those start byte to end byte locations to only get back from the file system that host item that I'm working on. So when you get over 30, 40, 50 megs in a file, it starts to become memory intensive to try to load that entire thing into memory and then deal with it. So rather than doing that, we load them one at a time. And the way that I, at runtime, create this library is using this add type definition, and then just the string of that source code, right? Tell it the language is C#, and it compiles it at runtime and loads the library into the run space. Right? So you can write C# code. Okay. Give it your own namespace, give it your own class names, give it your own functions. Okay. Add the type, and then in the same utilities, here I am using the class that I built higher up in that script, and the function that I built. Search for those bytes in this file. Return that array. And then return to the calling function a list of file locations. Okay, and I'm also have a get file bytes that takes a start location, end location, and using the .NET IO file stream and IO memory stream, it reads those bytes off of the file into a memory stream and then stores that memory stream into a byte array and returns that byte array. Okay, so that's how I read just a specific start byte to end byte off of a file. Don't have time to go too deep into it, but it's on the disk. Clean up. And then this one invokes pretty much the same thing, other than rather than returning just the bytes, it returns a string object using the encoder.getString. Okay, here's where it's telling you that I use the stopwatch to work with it. Okay, reset it back to 0. Start it each time. Here's where I'm using that custom log function. Save stuff out to the log file. Alright. You start reading the top of it. Get the length of the file. Get how big the file is. Check to make sure that it's got a Nessus v2 file header. That Nessus client v2 node, so that I know that I'm reading an XML file that's actually going to work for me. And then check to see if I've already imported that file. If not, go through, grab where it says the first host is, subtract 500 bytes, look for the report string, so I can save what the Nessus report name is. Go through, this is part of saving it, that's adding it for access. I use the right progress to keep the progress bar up at the top, which you guys will see. Take the number of items in that host count array and finding all of those host lists. And go through, pull the bytes, process the bytes, stop my timer, tell me how long it took to do that, tell me how long it took to do the entire host, and then clean up at the end. So I import this module, right? Close this guy out. Okay. Back in here. Right. Here's all of my Nessus files. Okay. Do get child item, get the Nessus file names if I wanted to import all of them. All right. Before I do that, I'm store a variable of that database that I copied. Okay, but I don't have to type it in. And here, get child item, enter w star dot Nessus. That'll make it so that I'm not picking up that all.nessus. Alright, push that into my custom module that I built. Database. It's my database. And trace There's a flag to turn on all logging. Powershell keeps affecting it. Database. Oh. Database. This was built off Office 2010. In Office 2013, they upgraded. Alright, upgrade my office. Can't get this to work in 5 seconds. Just call it off. Try this in 64 bit. Nope. Alright. I was working before, but apparently there's something up with this system. It wasn't on my other system. So, anyways, I'll have to troubleshoot that. If you're interested in that, let me know. This is out on GitHub. It's out on GitHub. Anyways, yeah. So, sometimes you win with PowerShell, and sometimes PowerShell wins with you. So, this is having a problem with the Microsoft base.oledb driver. For some reason, it's not picking up the Microsoft Access that's installed on the system, so it's not able to connect to the database, so it's not running through. It's one of the reasons why I'm looking at pulling off of this and going to Windows, SQL Server CE, because then I know where the binaries are, I know where the DLLs are, and I invoke it directly. So, alright, are there any questions? Sorry for the anticlimactic finish. It really does look cool when it works. A whole bunch of scrolling log files. Alright. So the GitHub page is github.com/grignac/ps-messis-accessdb. Pull it up. Do this for you guys. So we'll go ahead and figure out what it's doing, add some additional conditional logic based on if you have 64-bit Office versus 32-bit Office. Update it, to make it so that it'll build the connection string regardless of which environment that you're in. Alright, that concludes my speech.